Continuing in the path of our deep learning, in this video we are going to perform the task of binary classification on the text data. To start with, I'm importing my necessary libraries. So I'm importing my Tensorflow library, NumPy as well as Matplotlib library. After importing my necessary libraries, here I'm downloading my dataset. The dataset which I'm going to use in this video is IMDb text dataset. And this dataset is available inside the Tensorflow library itself. Hence, I have written as from tensorflow.keras.datasets import IMDb. And after importing this IMDb object, I am loading my data. I am loading the data as imdb.load_data num_words is equal to 10,000. So what does it mean? Let's go to the official documentation, guys. So I'll just click on this URL. Okay, so this takes me to the official documentation of this load_data method. And if I come over here, it says num_words. Yes, it says the data type will be integer or none. Words are ranked by how often they occur in the training set, and only num_words, most frequent words, are kept. So what it means is, when I load this dataset, the number of unique words from my dataset that will be collected from this IMDb will be 10,000. If I leave it as none, it will take the maximum available of unique number of words. But if I specify as num_words as 10,000, it will only take 10,000 most repeated words. Okay, so let me just execute this cell. This will download the data and it will save as train data, train labels, test data, test labels. And if I display the shapes of training data and the test data, the shapes are 25,000 and the 25,000. So what it means is, in total I have 50,000 rows of data, out of which I have 25,000 rows as a training data set and the remaining 25,000 as a test data set. Since it's a single dimensional vector, what we can think of it is like, it would be something like this. So training data, it will be a single column and it will have the values which goes like this. And in each row, I'll have some text values. So this is how my data set will be. If I display the shapes of training labels, so it is also a single dimensional vector which is of the length 25,000. Let's display the first instance on my training data. If I display the first instance of my training data, see, can you observe it? It is in the form of a Python list, and in this Python list, it contains integer values. So what does it refer? Yes, these integer values refer to the index of the word which is actually present in that particular instance of that row. So let me show you what that particular index means. So if I want to get the word index, I can make use of the method getWordIndex. So here I have written as wordIndex is equal to imdb.getWordIndex, and if I just execute this, this will show the complete word index of this particular IMDb dataset. Can you observe it? So here the word affords has the value as 17641, word concert has the value as 3249. So these are nothing but the integer encoding of the individual unique words in my dataset. So if I go back to my first instance that I got just displayed, see, the training data 0 has the values as 1, 14, 22, 16, 43, 530, 973 and so on. So what does it mean? It is referring to the respective words that are present in that first instance of the data. So that is how my dataset is currently structured. Now I have a question for you guys. Can I use my dataset as it is, just like I have in the form of encoding? No, isn't it? I cannot use the encoding as a form of representation for my machine learning model. I have to come up with some sort of upgraded method. So one such easy method can be something like one-hot representation. So let's see how to perform that. Now before we go into the one-hot representation of my text data, let's look at the value presented at the first instance of my training labels. The first instance of my training label has the value as 1. So that means the data which I had earlier displayed for training data, that represents the positive sentiment sentence, or in other words, review. And if I display the train labels 1, that is the second instance on my training data, it has the value as 0. So that means it's a negative sentiment sentence. Okay, we have now understood about the dataset, and we have understood that in case of training data, I have the words which are encoded in the form of integers. Since I cannot use the integer representation or on this integer encoding as a direct input for my machine learning model, we are going to perform the text transformation. To perform the text transformation, I have written a function as one-hot representation. This one-hot representation function takes two inputs, sequences and the dimensions. And inside this function, I have written as results is equal to np.zeros len of sequences comma dimension. So that means inside this function, I am instantiating a matrix, and this matrix is filled with zero values. So all the values will be filled with zeros, and this will be having the shape of length of sequences, which is nothing but the total number of instances present in my input data set. Suppose if I'm sending my training data, then the length of sequences will be 25,000, isn't it? So the length of sequences will be 25,000, and the dim by default it is 10,000. The reason I'm sending as 10,000 because if you remember, while we were importing the dataset, we have specified as num_words as 10,000. So that means by maximum, I'll be having the 10,000 unique words. So how does my input matrix will be? So my input matrix will be something like a matrix which is of the dimension 25,000 into 10,000. So this will be the dimension once I perform the one-hot encoding with this function. So let's see what it is performing over here. Here, after instantiating my results matrix, I have written as for I comma sequence in enumerate sequences, results I comma sequence is equal to 1. So that means wherever a particular integer value is present, then on that specific index, I am marking it as 1. And finally, I am returning that specific vector. In other words, I am returning that particular transformed matrix in the form of one-hot representation. I know this sounds very confusing if you're seeing it for the first time. So for the explanation purpose, I have written one more function, and instead of dimension as 10,000, I have written as dimension as 8. And inside that function, I have written the functionality just like I had written before, guys. So I'll just execute this. And after that, I have instantiated a Python list. And this Python list has the values as 1, 2, 3, 4, 4, 5, 6, 2. Now let me explain as what happens if I send this particular Python list into my one-hot representations text function. So when I send this Python list into this function, that is one-hot representations text, as a first step, it would generate a matrix which is of the shape of length of sequences. So what is the length of this particular Python list? 1, 2, 3, 4, 5, 6, 7, 8. So it will be having the 8 rows and the number of dimensions is 8. So I'll be generating a matrix which is of the dimension 8 by 8. After creating my matrix which is filled with zeros of the dimensions 8, 8, I'm going to transform each row like this. Here I'm going to loop in for each of the values in this particular Python list, and wherever that particular value 1 is present, in this case, let's say for the first instance, I have the value as 1 present over here. So what I'll do, wherever I have the index column as 1, at that time I'll mark as 1 over here. Okay, rest everything will be 0 as it is. And if I take the second instance, here I have the value as 2 over here. So what I'll do, wherever I have that value 2 over here in the column, I'll mark as 1. Remaining everything will stay as 0 as it is. And in case of 3, I'll mark as 1 over here. Remaining everywhere, it will be zeros as a default because I had instantiated my matrix of np.zeros. Similarly, 6. So if I have a value like this, 6, I'll have zeros everywhere except the column 6. So in this way, I'll be performing my one-hot representation of my integer values. So if I have 1, 2, 3, 4, 5, 6 integer values like this, each integer values is now represented in the form of one-hot representation, which is a linear algebra method of representing the vectors. Okay. Now let's send this and let's execute this. So once I send this particular Python list into this one-hot representation text, see, I have the output just like I had explained. In the first instance, wherever the column index is 1, only at that place I have the value as 1, rest everywhere I have it as 0. And for the second instance, I have the integer value as 2, hence wherever the column index 2 is present, at that place value 1 is filled, rest everywhere 0 is present, and so on. And if I look at the final instance, at the final instance I have the index value as 2, so On that index value, I have the value as 1, rest everywhere it will be zeros. Okay. Now the next question is, what happens if I send my entire training data? So what does it do? So when I send my entire training data, what it will do is, let me execute this and let's analyze from the shape that we get. So if I send my entire training data, I'll be getting the resulting shape of 25,000, 10,000. In case of our training data, each row, or in other words, each instance of my training data will have multiple values. The multiple values can be something like this. So it will be a Python list. It will have some multiple values like 23, 45, 10, 100, and so on. So I'll be having a multiple values in my Python list. And when I send this Python list, which has the multiple values, for each row, what it is going to do is, it is going to create a one-hot representation vector, and this will be having the length of 10,000. And wherever that particular integer value is present, in this case, let's say 23, at that integer, at that index value, 1 will be filled. And 45, at that index value, 1 will be filled. 10, at that value, at that index position, value 1 will be filled. 100, at that index position, value 1 will be filled. Rest everywhere, it will be filled with zeros. So instead of having a Python list with values filled with integers, we'll be having a one-hot representation which are in the form of binary, and each instance will have the equal length, that is 10,000. Okay, so that is what it does. So we have transformed our training data as well. Now once we have the training data ready, we are going to apply it to our deep neural network. To start with, I'm importing my models and layers from Keras module. So from tensorflow.keras, import models.layers. After loading my models and layers, I'm instantiating my model as sequential, and after initializing my model as sequential, for the first layer, I have set the number of neurons as 16 and activation as ReLU, and the input shape is 10,000. The reason because each instance on my training data is transformed into a one-hot vector of the length 10,000. Okay. And in my second layer, I have the dense layer. It has 16 neurons and the activation is ReLU. And on my final layer, I have set the activation as sigmoid with single neuron. And after that, it's same guys, I'm going to compile my network. So for compilation, I have made use of optimizer as RMS propt and the loss as binary cross entropy, and the metrics is accuracy. And after that, what I'm going to do is, here I'm transforming my training data and the test data and saving in the variables of xtrain and xtest. And from this training data, I'm splitting it again for the validation data and the training data. So from my training data, I'm again splitting into two parts, that is validation data and the partial train. So I'm going to train my machine learning model, in this case deep learning model, with the partial training data, and I'm going to test my accuracy with the validation data. And on the basis of this model functionality, I'm going to find the evaluation on my test data. Okay, I'm going to execute this. After this, I'm going to perform the fit using x partial train and y partial train, and number of epochs as 15, batch size as 512, and the validation data as xval, yval. So I'm going to execute this. Okay, so the system is executing. Can you observe the output guys? So after the third epoch, I can see that the validation accuracy is decreasing. So on my third epoch, the validation accuracy was 89%. And from the fourth, it started decreasing and on the fourth, it became 88.99. And on the fifth, it became 86.81. And sixth, it became 88.41 and so on. So what it is doing? After third epoch, it is performing the overfitting. Let's create a plot and analyze as how the plot looks like when we plot validation accuracy versus normal accuracy on the training data. So to get these values, we make use of the object of history. So I'm writing as history_dict is equal to history.history. So this would result in a dictionary which has the keys as loss, accuracy, validation loss, and validation accuracy. So I'm going to write as history_dict is equal to history.history, and after this, I'm extracting my value of the accuracy as history_dict and specifying my index as accuracy, and in the same way I'm extracting my validation accuracy, loss, and validation loss. And if I plot my training loss versus validation loss, see if you observe the output, until the third epoch, the validation loss is getting decreased along with training loss. But after the third epoch, the system starts overfitting, and we can observe the same over here. So after the third epoch, the validation loss didn't improve, and even it became worse at the fifth epoch. So that means my model is clearly performing the overfitting. Now, how to counter this overfitting, we will look in detail in the future videos. But one of the easy method to counter this particular overfitting is with the help of early stopping. The early stopping means we will stop wherever the validation accuracy starts degrading. In our case, the validation accuracy starts degrading after third epoch, isn't it? So as a next step here, what I have done is I have run my network.fit with epochs as 3. So once I do that, I'll get the required accuracy. In this case, the maximum accuracy my system was able to reach on the validation data was 0.86. And on this trained model, I'm going to perform the evaluation on my test data. Once I perform the evaluation on my test data, I am getting the accuracy as 85.27. So in this video, we have learned as how to perform the one-hot encoding on my integer values, and using those one-hot encoding representation, how to perform the binary classification. I hope this video has been useful to you, and if you have any requests to cover any other topic, do let us know in the comment section, and I look forward to see you in the next class.